Hi, and welcome back to another junior relations video. In this video, we're going to start to tie together the stuff you've been doing in the first couple of videos, how sequences and 2D graphs connect. All right, straight into example number one. Right, we've got a pattern which is going to be made up of a number of shapes. So here's shape number one, and I need 4 lines or 4 sides to draw that shape. Here's shape number two, and I've added on 3 more sides. So here's shape number 3, and I've added on 3 more sides. So let's go back. This shape here needed 4 lines or 4 sides. This shape needs 3 more lines, so a total of 7 lines. This shape needs 3 more lines added on, so a total of 10 lines. So we've got the start of a sequence, 4, 7, 10. It's a linear sequence because it's going up the same amount every time, and it's going up in threes. So the next number would be 13 and the next number would be 16. Right, so now we're going to show you how we can take that sequence and draw a two-dimensional graph. Here's the graph here. On the x-axis, we have the shape number. Now the shape number, let me just back up the bus. The shape number represents what shape we are. This is shape number 1, this is shape number 2, this is shape number 3. So that's what the shape number represents on the x-axis. On the y-axis, it's the number of lines to draw the shape, sorry. All right, so here's the actual graph here. Let's just work through what these points mean. Shape number 1 needed 4 lines. Shape 2 needed 7. Shape 3 needed 10. Shape 4, which would look like this, would need 13 lines. And shape 5, which looks like this, would need 16 lines. All right, well, it's called a linear sequence because I could draw a straight line between them all. I'm not going to draw a solid line, it's just a dotted line. Actually, I'm not going to draw a line at all. I'm going to take the line off because what we can't do is we can't have shape number 2.5. We can't say how many lines does shape 2.5 have, and that just doesn't make sense. So we're actually going to remove the line and just have the dots, which represent the numbers for the sequence. Right, we talked about this linear sequence. Okay, let's move on to example number 2. Here we go. Here's shape number 1, it needs 1 dot. Shape number 2 needs 3 dots. Shape 3 needs 1, 2, 3, 4, 5, 6 dots. And shape 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots for shape 4. Right, so shape 1 needed 1 dot, shape 2, 3 dots, shape 3, 6 dots, and shape 4, 10 dots. Right, well, this is another sequence. We talked about this in the video on sequences. It's a unique type of sequence called the triangular numbers. It doesn't go up the same amount every time, so it's not linear. Right, shape 5 would need 15 dots. I hope you can see the pattern. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, so 15 plus 6 makes 21. Right, let's show you how we would draw a 2D graph. Here's our two-dimensional graph. On the x-axis, once again, it's the shape number. And on the y-axis, we've got the number of dots. Now I'm going to draw all the dots in. Here we go. And I hope you can see that. Shape 1 needed 1 dot. Shape 2 needed 3 dots. Shape 3 needed 6. Shape 4 needed 10. And shape 5 needed 15 dots. I didn't do shape 6, I've run out of space on my graph. Right, if I tried to draw a straight line between them, you can see that it just can't be done. I can't draw a straight line. It's not a linear sequence. We are not increasing the same amount every time, so it's not a straight line graph. Remember, it's called triangular numbers. Alrighty, I think that's us. So thank you very much for watching.